Welcome to Instrument Engineer channel, powered by InstrumentationPortal.com. This video will explain about instrument hookup drawing. Before we continue, don't forget to subscribe to this channel. This is a new channel, and producing more videos so that you will not be missed the new ones. We start. This is a picture of an instrument which has been put into service. It is a differential pressure type flow transmitter for measuring a pressure drop across the orifice. To measure the pressure, this instrument is not directly connected to the pipe, instead, it is connected to point of measurement by the tapping. We usually name the point of measurement by tapping point. However, before it is installed like arrangement, as shown in this picture, there must be a drawing that shows how the instrument is going to be installed. The drawing is produced during design engineering, and after that, is used as a guide by the technician who installs the instrument. And this drawing is known as instrument hookup drawing. So, hookup drawing is a detailed drawing, which is showing typical installation of instrument in a correct manner, so that instrument will operate properly during operation. By having a correct installation, it will not have any issue, which could potentially affect the measurement, such as liquid trap, in the impulse line, in the future. This is the instrument. And this side is the process. Between them is the bulk material that are needed to make the installation complete. So, what is the detail that we must specify in the hookup diagram? First, hookup drawing gives information the requirement of bulk material for each installation. As seen on the bottom table, it provides details of bulk material, including its specification, size, type, material, and the quantity. Next is to specify instruments within the plant which need this kind of installation. Like in this drawing, it is shown that there are 5 transmitters which will have this typical installation. Hence, the bulk material in the previous table must be multiplied with this number of instrument to obtain the total number of bulk material required for the project. This drawing also indicates position of instrument in reference to process tapping point. The gas service instrument will have the instrument position higher than the process tapping. Inversely, the liquid service instrument will have the instrument position lower than the process tapping. As you can see, this drawing is instrument serving for the process gas. It also shows tubing slopes. It should be noted that no pocket point is allowed. So it shall have a continuous slope from the instrument up to the tapping point. And scope limit between instrument and piping. Battery limit between instrument and piping shall be made clear. This is must in line with P&ID or piping documents. Last but not least, extra notes. For example, stating material or accessories that is supplied by other party and not being counted in this drawing. In this example drawing, it is stated that 5-way valve manifold, orifice flange, mounting bracket, and U-bolt will be supplied by other party and is not counted in this bulk material. There are 2 types of hookup drawings. Process hookup. This hookup drawing contains typical installations for instrument which connects to the process. Pneumatic hookup contains typical installations for instrument which requires instrument air, such as control valve and actuated valve. What is the purpose of instrument hookup drawing? As stated earlier, information of bulk material requirement is stated for each installation on each sheet. Hence, the bulk material required for the whole drawings could be summarized and tabulated in a document named Material Takeoff. During project construction phase, this drawing is also referred as a guidance of how to install the instrument properly. Please subscribe to our channel, since we will be releasing a new video. Or visit instrumentationportal.com for more instrument and control related content. Thank you. Welcome to Instrument Engineer channel, powered by instrumentationportal.com. This video will explain what shutdown logic diagram is. Before we continue, don't forget to subscribe to this channel. This is a new channel, and producing more videos so that you will not be missed the new ones. Okay, we start. The operation of oil and gas facilities involves high inherent risks due to the presence of dangerous material, like gases and chemicals. The risks due to dealing with highly combustible materials, high-pressure system, and existence of toxic gas, such as H2S. This hazard could result in accident if it is not handled and monitored thoroughly. In order oil and gas facilities can operate safely, several protection layers are needed to protect the entire facilities. There are 7 items that constitute protection layers. Process design. Basic process control system, including process alarms and operator supervision. Critical alarms and manual intervention. Safety instrumented system. Active physical protection, such as relief valve. Passive physical protection, such as dikes or blast wall. And emergency response procedure. If an incident occurs, these layers shall protect the facilities. And if a particular protection layer fails to handle it, then the higher protection layer is expected to provide protection and handle the hazards that occur. In this protection layer, there are layers that work with automation, basic process control system, and safety instrumented system. Safety instrumented system, or SIS, has some other names. Safety shutdown system, or SSS, and emergency shutdown system, or ESD. The term SIS is more widely used, and this term is also used by the ISA committee. Process Control System, or PCS, and Safety Instrumented System, or SIS, consist of sensors, controllers, and final elements. It should be noted, Safety Instrumented System and Basic Process Control System must be fully separated from the sensor up to the final element. In this picture, there are pressure transmitter and control valve that are part of the PCS, and there are pressure transmitter and shutdown valve that are part of the SIS. Control system for the safety instrumented system must be programmed by entering the logic that is specified in the shutdown logic diagram. The objective of SIS is provide protection for the personnel, environment, and equipment. That objective can be achieved by automatically sensing an abnormal condition of operation, automatically reacting to these conditions by generating the correct outputs to prevent or mitigate the hazardous event, providing additional manual facilities for shutdown and isolation, and depressurizing the platform, providing audible and visual shutdown status information to the operator and platform. This is a simplified shutdown logic diagram. It looks like a tree diagram. The rectangle is a symbol for the input or a predetermined condition that is considered to be unsafe. This could be sensors, such as transmitter, switches, or fire and gas detectors that detect abnormal condition. Push button or hand switch. Interlock or logic input from the system. This is a signal which is initiated by control system if several predetermined conditions have been fulfilled. The hexagon is an output or an action that needs to be performed by the SIS. These can be solenoid valve to actuate pneumatic or hydraulic valve, to run or stop pneumatic pump, and to release extinguishment breaker. To isolated power supply for start or stop electrical powered equipment. Alarm, such as visual alarm or beacon, and sounder. Interlock. In oil and gas facility, there is hierarchy of shutdown level. Typically it consists of USD or unit shutdown, PSD or process shutdown, ESD or emergency shutdown, EDP or depressurized shutdown. The initiation of higher level shall cause lower level shutdown action to occur. The most bottom level is unit shutdown. USD is shutdown of individual process or utility equipment or vendor package. Unit shutdown is initiated to prevent equipment from operating outside preset process limits that may cause damage to the equipment or adversely affect the process. The next level is PSD or process shutdown. PSD will shut down and isolate all related process equipment or systems to limit the probability of an abnormal operating condition, which can lead to an emergency situation. However, utility system will remain operational if possible. Next is ESD, or emergency shutdown. ESD will shut down and isolate all designated process-related equipment, including inlet and outlet of plant ESD valves. ESD is initiated by abnormal critical process variable. The highest level is EDP or emergency depressurize. EDP will shut down, isolate, and depressurize all equipment, and opening of the depressurizing valve, or usually named BDV, or blowdown valve, to flare. EDP is initiated automatically if there is a detection of fire or gas leak in the facilities. This can be triggered by confirmed fire or gas, which is a coincident detection of two or more fire or gas detectors. Please subscribe to our channel, since we will be releasing a new video. Or visit instrumentationportal.com for more instrument and control related content. Thank you. What is a loop drawing, or also named loop diagram? Loop diagram is a drawing which shows detailed connection from one point to control system. Okay, here are what's shown in the loop diagram. Instrument and its terminal numbers which are to be connected. Instrument cable number, junction box number, and the assigned terminal number inside the junction box. Multi-pair cable and its pair number. Marshalling cabinet number. The assigned terminal number in marshalling cabinet for the specified instrument. Termination board or field terminal assembly, FANI. Control system details, such as controller number, I/O type, rack number, slot number, and I/O channel. Loop diagram also clearly indicates the location of each equipment by means of borderline as a limit. Next, we will discuss about how these information are obtained. In instrument section, most instrument terminal number is assumed to use plus and minus terminals. However, instrument which needs special arrangement, such as smoke detector, or instrument which in series loop, will require manufacturer connection detail to make the cable properly connected. Cable number is obtained from cable block diagram drawing. This is the junction box section. Junction box number and multi-pair cable number are obtained from cable block diagram. Terminal block number and terminal number information are from JB wiring connection document. This is the marshalling cabinet section. Marshalling cabinet number is provided in cable block diagram. Terminal number could be obtained from marshalling wiring connection, which is usually prepared by the control system vendor. In addition, if termination board or field terminal assembly is used, the information also shall come from control system vendor. And last, in the control system section, I/O point detail information, such as card type, rack number, slot number, and channel number, are provided by system integrator or control system vendor, which is available in the I/O assignment document. The loop diagram that we discussed before is loop diagram for field instrument, as shown in below diagram. Another type of loop diagram is the connection between unit control panel and control system, motor control center, or electrical panel, and control system, and one control system and another control system. Loop diagram usually shows a single control loop, which means it only contains just one input sensor to control system or one output control system to final element. However, it could also a combination of both if it is a closed loop. The purpose of instrument loop diagram is for checking the connection between instrument and control system. It becomes a reference during pre-commissioning, commissioning, and troubleshooting during operation. Please subscribe to our channel since we will be releasing a new video, or visit www.instrumentationportal.com for more instrument and control related content. Thank you. What is an input-output list? Or mostly said, I/O list? I/O list is a document which contains list of instrumentation serving as an input or output of control system. Only tag number that physically has a cable which connects to the control system will appear on I/O list. For example, transmitter, switches, push buttons, detectors, solenoid valve, positioner of a control valve, and alarm. Okay, this is a simple piping and instrumentation diagram. As been mentioned previously, from this P&ID, only the following tag numbers will be included in the I/O list document: pressure transmitter, flow transmitter, valve positioner, level transmitter, level switch, valve positioner, solenoid valve, limit switch close, limit switch open. When there are more than one control system in a plant, let's say PCS, SIS, or FMG, the I/O list shall clearly indicates which instruments is assigned to which control system, or may separate them to different section of the document. In I/O list, the following information should be stated for each tag number as minimum: tag number, loop number, service description, P&ID number, type of instrument, location, I/O type, control system, and range or set point. The information column, in which I/O list contains, may be as simple as in the previous slide. However, some projects require I/O list to be detailed by having alarm set point, controller action, and logic 0 or 1 descriptor. In the next step, input-output list will include I/O number assignment, such as rack number, slot number, channel number. This information will be provided by control system vendor. For preparing input-output list, we need instrument index as a reference document. Filter all tag numbers in the index that has an input-output to make the I/O list. I/O list is used to determine the size of control system required by project. When the input-output list has been completed, the I/O will be counted for each control system within a plant. It also becomes the references for I/O-related control system information once plant has been put into operation. Please subscribe to our channel since we will be releasing a new video. Or visit www.instrumentationportal.com for more instrument and control related content. Thank you.